Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0A94-01, indicates a problem with the DC-DC converter in the 2023 Honda CR-V. This code can be triggered when the Powertrain Control Module, PCM, detects a failure or malfunction within the DC-DC converter system. The role of the DC-DC converter is crucial as it helps in converting high-voltage battery power into appropriate voltage levels that can be utilized effectively by various vehicle systems. The PCM functions as the brain of the vehicle, analyzing inputs from various components and determining operational abnormalities. If the PCM identifies an issue with the DC-DC converter, it generates this specific DTC and stores it, indicating that troubleshooting is necessary. In this presentation, we will explore a comprehensive troubleshooting guide to help identify and resolve the P0A94-01 error effectively. DTC P0A94 pertains to a performance issue with the DC-DC converter in the Honda CR-V. The components directly impacted include the DC-DC converter and the PCM. The DC-DC converter is typically located near the hybrid battery unit in the vehicle and plays a critical role in ensuring that proper voltage levels are maintained for different electrical systems. In essence, it converts the high voltage from the battery to lower voltages suitable for electrical systems. Meanwhile, the PCM is often located in the engine compartment or cabin and processes data from multiple sensors to determine if the DC-DC converter is functioning properly. If the PCM receives failure signals from the DC-DC converter, it registers this error, necessitating immediate inspection and troubleshooting to ensure vehicle reliability. When addressing DTC P0A94-01, it's vital to consider several potential causes. A primary suspect is a failure in the DC-DC converter itself, prompting the PCM to identify a malfunction. Additionally, wiring issues such as short circuits or open circuits in the DC-DC converter connections may contribute to the problem, causing improper responses and triggering the DTC. The PCM may also suffer from faults or incorrect configurations that lead to misinterpretation of the DC-DC converter's performance, falsely indicating a failure. Understanding these factors is essential in determining the proper pathway for effective troubleshooting. By systematically approaching these potential causes, technicians can narrow down the source of the issue and implement the right repairs. The symptoms associated with DTC P0A94-01 can manifest in various ways. One common indication is the illumination of warning lights on the vehicle's dashboard, signaling the driver that a hybrid system issue exists. Drivers may also notice performance issues such as reduced acceleration or strange shifts in electric assistance, which are indicative of electrical circuit malfunctions. In severe cases, the vehicle's overall battery performance may decline, leading to unexpected shutdowns or a failure to start. Drivers may experience noticeable hesitations during operation, which can be both alarming and disruptive. Recognizing these symptoms is crucial for timely diagnosis and repair, minimizing potential further damage to the vehicle's systems. In the first step of troubleshooting DTC P0A94-01, a test drive of the vehicle is conducted to assess its operating conditions under real-world scenarios. During the test drive, the technician must carefully observe the vehicle's performance and listen for any unusual sounds or operational anomalies that could indicate a problem. After the test drive, the technician will test the engine stop function using the auto idle stop feature, which allows the engine to shut off automatically during idling. This feature is instrumental in hybrid vehicles for improving fuel efficiency and minimizing emissions. Observing how the DC-DC converter reacts to these conditions can provide insight into whether the system is functioning properly. Any irregularities noted during this process should be documented for further analysis. The second troubleshooting step involves inspecting the external circuit associated with the DC-DC converter. It's essential to look for shorted wiring, especially in the DC_STS circuit, which could directly impact the performance of the DC-DC converter. To perform this inspection effectively, the technician must first disconnect the DC-DC converter connector and then check for continuity using a multimeter. An ideal condition would show more than 1 million amp-ohm resistance when the circuit is tested. A measurement of less resistance may point toward a short circuit, necessitating further investigation. This step forms a foundation for ensuring that no external wiring issues are affecting the normal operation of the DC-DC converter. Should any shorted wiring be identified, appropriate repairs must be made before proceeding. In the third step, attention shifts to the specific components themselves, particularly the DC-DC converter. This step involves inspecting the output circuit of the DC-DC converter to determine whether it is producing the correct voltage levels. Any abnormalities in the output readings can lead to error detection by the PCM. Testing the internal circuits of the DC-DC converter is equally critical. While direct testing may not be feasible, technicians can assess related components to ensure they are functioning correctly. This can include verifying proper terminal connections, checking for signs of physical damage, or corrosion, which may affect performance. A thorough examination at this stage is vital to establish whether the problem lies within the DC-DC converter or another associated system. The fourth troubleshooting step focuses on inspecting the powertrain control module, PCM, itself. If previous inspections yielded normal results for the DC-DC converter and its circuits, it becomes necessary to investigate the PCM as a possible source of the problem. This assessment involves checking for any stored DTCs other than P0A94-01 and analyzing the captured data for electrical inputs and operational commands. If the PCM is determined to be faulty, it may require reprogramming or replacement to restore functionality. It's essential to pay attention to any unusual readings or patterns that may indicate errors in signal processing. By isolating the PCM as a possible culprit, technicians can confirm whether this component is the root cause of the malfunction. After performing repairs based on the previous troubleshooting steps, the final verification stage involves confirming that the issues associated with DTC P0A94 have been resolved. This is done by retesting the vehicle under the same conditions as the initial test drive, focusing on ensuring that the DC-DC converter and its related components are functioning correctly. An observation for the absence of warning lights and smooth operational performance is crucial at this stage. Furthermore, the technician should utilize diagnostic tools such as the Honda Diagnostic System, HDS, to check for any reoccurrence of DTCs. Successful completion indicates that the system is now functioning as intended and the repairs have been effective, ensuring peace of mind for the vehicle owner. To mitigate future occurrences of DTC P0A94-01, implementing preventive maintenance is essential. Regular inspections of the DC-DC converter and its connections help in identifying potential issues early on. Using the HDS to monitor and, if necessary, update the software in the PCM regularly can also improve system resilience. This not only ensures that the systems are running on the latest protocols, but also helps in minimizing the chances of misinterpretation of component performance. Additionally, maintaining the vehicle's electrical systems and battery health will ensure that the DC-DC converter operates efficiently. Proactive measures, alongside periodic professional checkups, can substantially enhance the reliability and longevity of the vehicle's performance. In summary, troubleshooting DTC P0A94-01 in a Honda CR-V involves systematic inspection of the DC-DC converter, its circuits, and the PCM. Identifying potential causes and recognizing symptoms are pivotal in the early stages. Each step, from conducting a test drive to verifying repairs, plays a crucial role in ensuring that the vehicle is functioning optimally. Emphasizing preventive maintenance through regular inspections and software updates will serve to alleviate the likelihood of recurrence. Understanding these aspects is vital for both technicians and vehicle owners to ensure sustained vehicle performance and reliability. Ultimately, a thorough approach during diagnostics and repairs enhances the driving experience while minimizing the potential for future issues. Please like and subscribe to the channel. See you next time.